Hi there, I'm Chip Boling. I'm with the Tibit Communications, and we're here to talk about our experience in implementing SEBA with a Microplug OLT. And I'll go through some of the information just on what a micro OLT is, some of the basic functionality that it has, how it works within Volta and within the SEBA environment. And then we'll go into how what we had to do to get that integrated into a Kubernetes environment, some of the problems that we had related to versioning, to protocols. And about slide 5 or so, there's a good overall general picture of what the setup and the solution was that we have at this point. So during the talk, if there's any questions or anything, please ask, especially as we get towards slide 5 of why we did something or why didn't we do something, because I think that could generate some really good information and discussion points. And then we also have some information on how it actually looks within SEBA as from a demo point of view. So Tibit has one of their main products that we have is a Microplug OLT. And what a Microplug OLT is, it's a 10 gigabit OLT that's in a single SFP plus transceiver package. So that, with respect to Volta, it's ITU G987 XGS PON compliant, so it provides all the plumb capabilities, all the optics, wavelengths, all that is pretty much built onto the actual device. It also does, it's a 10 gig PON max, so it also does EPON. So basically with just a configuration switch without even changing the firmware, you can go to EPON mode. I'm most familiar with XGS PON, so we can get you in touch if you have EPON questions with someone else. Also on the Microplug, there's a 32-bit RISC CPU, so most Microplugs will have just enough capability to do the I2C, to do some of the monitoring and normal capabilities for temperature and voltage that it needs to report back up to its host switch. But since this is a Microplug OLT and it has a bridge MAC on it, there was need for a RISC CPU or some more capable CPU to be able to handle all the firmware tasks beyond what you normally see on a Microplug OLT. So we have in-band management capabilities, which is provided over on IEEE 1904.2 link or protocol link. It also has to be able to interpret and monitor the bridge for all its capabilities, because it has to be able to apply in the firmware all the SLA capabilities for upstream and downstream traffic, plus all the small tasks that you have in Plum to actually handle the PON layer. So, and what it does not have is it doesn't have what you typically have on a larger pizza box OLT. So you don't have to worry about fan drivers, because there's no fan needed. So since it's just a couple watt device, but you also have in the existing implementation. Sorry about that. Let's see, where was I? Oh, and what it does not have is it's pretty much was designed initially as a disaggregated OLT, so the control plane to do any kind of processing of, say, DHCP packets for DHCP relay, PPOE, AAA, or those other capabilities, those were all initially intended always to be done on an external process. That external process could be, something running the in-band management protocol within the actual device switch itself. It could be an external PON controller, custom software, or in the case of Volta, it's actually Volta. So that's some of the main differences between the two capabilities. And so a few of these actually come up a little bit later on. So one of the things that we did find out since the 1904.2, it's a layer 2 capability. So when you're running Docker Compose in a normal Docker environment, going out and creating extra interfaces to do a layer 2 communication back from Volta into the actual OLT. That was fairly easy. You know, that took no trouble at all. The first problem came along is that pretty much every carrier does layer 2 transport within their CO or within their test environment completely different. So we would see people actually just do straight Ethernet connections. Others do VLAN. Some people do L2TP, and some people do VXLAN, just depending on what they wanted to do. So I was immediately, when I was working on the Volta adapter, you know, most of my time was trying to debug how do I get from Volta to the OLT in this environment. And then as you go into Kubernetes, it gets a little bit more difficult because Kubernetes is a much more different networking model. So my bigger hurdle was actually learning that. I was fairly familiar with Kubernetes, and I could work my way through a Helm chart, but when you get into the actual Kubernetes networking and all the magic that actually goes behind there on the different CNI plugins, that becomes a little bit more interesting on how you actually do that. So that's some of the basic information just on the micro OLT. Hagen has some information on some of the other sides. On going into some of the reasons where micro OLT or Microplug would actually fit in some environments. And
hello. So I think from the next slide onwards, you find my famously misdesigned. Hello, yeah, my famously misdesigned slide design. We actually had to solve two problems. One is how to get the layer 2 management traffic up into Volta, up into a Kubernetes container. And the other one is how to make those pluggable OLTs work in the leaf switch of a leaf spine fabric. So that means these are now up to 48 of those pluggable OLTs that you can run on a potential leaf switch. So we want to save on boxes. So we not necessarily want to have a separate pizza box. Probably Delta sees that differently. For just being the OLT or being in the place of a standard OLT. We wanted to see how we can run one switch with essentially two control interfaces to be controlled under Trellis as well as under Volta. And that turned out to be a pretty tricky one. So, as you all know, ONOS is the controller for Trellis. And the OLT control is typically done using Volta. So Volta itself presents itself as an OpenFlow switch to ONOS. Now, that turns out we actually have two control interfaces on an OpenFlow switch because that's what we wanted to take for Trellis. What we needed to do is to create a second control interface, and that's then what BISDN, to answer your question, normally does, is tinkering with white boxes and having operating systems and having SDN controllers and so on. So what we do is we created a gRPC server on the Delta box alongside the OpenFlow. And the gRPC server with the protobuf actually programs directly on the OFTPA API. It could as well go down into the SDK. We decided for the OFTPA API. So we can now create a VXLAN endpoint directly on the box that then is able to pull the layer 2 management traffic up into Volta, whereas we still have the OpenFlow control traffic coming from ONOS for Trellis. So it's a bit tricky, but we actually managed this. The last line here is having two control interfaces means we need something like what was called a flow visor. We actually need to slice the control between the two potentially competing controllers. So I have now, actually the practical problem is if ONOS sees an OpenFlow switch, it tries to set flow mods onto each and every port. I may have ports that I don't want ONOS to touch because these are now my access ports. So I need to make sure that certain ports are configured and while others are not configured through ONOS. So I think this is slide number 5, right? Yeah. This is the famous slide number 5, which contains all the information that you want to take away. So this is how we did it. Let's start from the gRPC switch configurator. That is now a part of the Tibit adapter, which is a container running in Kubernetes that can create via the management port a VXLAN endpoint here, as well as here, and this is then actually going through a data port on the white box switch, and up here ends in the Kubernetes. This way, the management traffic, this famous VLAN 4090 that you decided to take for this, is being encapsulated into VXLAN, sent up. And that's practically it. So these are the 2 control endpoints that we did. And you want to add something?
Yeah, I guess a couple of things would be we actually started with Volta 1.6 for this implementation. So that provided, we had some customers that had deployments and tests within their labs on Volta 1.6, and so that's what I was trying to harden our adapter for. So it gave us a very good point to start with inside Volta. So, but that also restricted us on the version of SEBA that we could run. So, we had quite a bit of, or I went through quite a bit of effort trying to find out and reconstruct the right version numbers for the SEBA to run on that switch. After I did that, then I ran into the problem that while most OLTs within SEBA are provisioned with an IP address or an IP address and data port, we're provisioned with the MAC addresses. So there was actually provisions within SEBA to support pre-provisioning and enabling OLTs with MAC addresses, but since no one had used it yet, I was the first one to actually go through and have to figure out and find a few of the bugs, and we'll be upstreaming those bugs if they're also in the latest tips of the SEBA, like in the Volt synchronizer. There's a couple issues that we have to do there. Let's see, I think there was
Multus versus handcrafted.
Oh yeah. The other one is actually how to best craft the extra networking port. So within SEBA, I think most of that, it's built with just Calico as the CNI. And so if you install Multus first, like in Mobile Core, they typically do Multus and then put Calico on top. So I went through some issues trying to figure out how to actually integrate Multus into the SEBA environment, and I came up to the limit of my Helm chart capability. So we had to sort of abandon that and look at actually using the IP command within Linux to actually move a physical device interface from the VM inside the namespace for the Volta core container where the device adapter was. So we've got some work to do to see how best to integrate either Multus as a base for SEBA if we wanted to run in that capability. But as we go to Volta 2.0, obviously the adapter goes into its own container, and we're at a much less restrictive environment or less imposing environment on the infrastructure. So whether we want to go and expend the effort of getting Multus working as the base of SEBA for this container networking, we might not really need to do that unless other people seem to have, they might want to do DPTK or some kind of acceleration capability in SEBA.
Well, I'll start with the first question. So the reason why it's going through I think is that because the switch itself is also an open flow switch. If you have a switch, it's not an open flow enabled switch, do you still need to, will the whole communication architecture change?
You mean if we're not running trellis?
If you're not running trellis, that's correct.
Then everything is easy. We can then we can hide the open flow part completely. We can control the switch in a different way.
Yeah. One way to think about it is like with the Microplug, you can easily integrate that into a small deployment. So it's a very cost-effective small deployment. So in that case, you might have a switch going straight into the aggregator to the BNG. You might not even actually have a trellis component. Well, okay, that would make a very quick and easy demo, but as soon as you get to a larger deployment, you are going to have a fabric, but in that large fabric, you could say, well, you know, the switch with the OLT will probably not be a top of rack and all, and that will go just as far until someone back in operations who counts dollars realizes that there's 4 ports free sitting on this top of rack switch that they could go and plug something into to get another PON port.
And what's the color coding on this one? So the VTP
is a separate data port. It's a data port used for control. So hence it has a different color than the regular data ports. And the green one is the actual control.
Yeah. And for people, the VTEP is the VXLAN endpoint. And one of the good things about selecting that is that if you up within the Kubernetes cluster, you can easily implement that with either like an OVS CNI plugin, because Open vSwitch supports VXLAN endpoints, and also like the Delta switch has it naturally supports VXLAN. So placing that VTEP actually on the port where the OLT is plugged into gives you demarcation point directly into the OLT. You don't have to do any kind of fancy LAN magic. You can just do MAC switching at that small point.
Thanks, Chip and Hagen. I'm Durga. I'm with Delta Electronics. So I would like to go over the topology. This is the topology we built in our Fremont lab. So I have 2 ONUs. So for one of the ONU, I have laptop connected, and I have a 1x8 splitter. And the SDN fabric is Delta white box switch. The model number is AG7648. I'm running BISDN Linux on top of the switch. And I have 2 Tibit microplugs. One is in port 1 and the other one is in port 5. So if you look at the MAC address, I have 2 MAC address down below. On port 8, I have a DHCP server. On port 17, I have ONOS and OLTA running in one of the servers. These are not the correct slides. Yeah, I think.
This might be a very basic question about your proposal, but could you tell me the reason why you selected to implement the control of switch in Volta, not ONOS? What is the reason?
The architectural reason for controlling the switch in Volta and not ONOS is we need the OLTs to be configured from Volta. And Volta normally would expose the OLT as a switch to ONOS. So what you're asking for is essentially to have Volta control ONOS from top. And that would sort of break the SEBA architecture.
No, this one's, I download, okay.
Yeah.
See, I'm not working on open source. Sorry. Pause recording, please.
Is there a way of plugging these OLTs into the compute nodes directly?
Not directly.
Was the question about putting it directly into the compute node?
Into the compute nodes standards.
Actually, if
This is
the
PowerPoint, yeah.
we've ran the OLT actually on like an Intel 10 gig NIC card.
Down low.
Yeah, in the
I
drive.
don't know what the version number is. I'm sure with some NIC cards they're very specific on what they're allowed. So it probably would depend on cooling capacity. Probably want to make sure there's some fan access to run it. But I mean it's SFP plus. So. You could
You could do lots of things integrating with DPDK also, like.
Yeah. Well, the DPDK would be well outside the OLT itself, so that would just be normal server software. So I don't know
If I may say, we have mixed experience with doing that. It works in some cards, it doesn't work in other cards.
Yeah, you need to qualify the card to make sure.
Sometimes we put a media extender in front of a card, so a media converter and like from 10G to 10G, and then it works.
Yeah, so coming to the SDN fabric, it's a Delta white box switch with 48 10 gig ports. So port 8 is actually connected to the DHCP server. Port 17 is connected to the OLTA and ONF server. So with this configuration, we are able to discover the OLTs. So the next slide shows that we are able to discover, this is the switch. Yeah, the DHCP server, yes. They both are same? Yeah, so the web server and the DHCP server are sitting on the same, yeah. So now we are able to discover the Tibit OLT. The Tibit OLT is configured with CTAG 4090. And this slide shows that we are able to discover the ONU, which is sitting behind the Tibit OLT. So our next step is to authenticate the laptop and have the DHCP address, like acquire the DHCP address, and then browse the web server. Yeah. Thank you.
What are your plans for, or at least thoughts on integrating with Volta 2.x, containerizing the adapter? Is there any benefits that you might see, any advantages maybe in moving the adapter to run on the switch itself, now that you could disaggregate it and run its own process? I'm just curious if there's any advantage in a 2.x setup that you might could simplify things a little bit.
I think probably the one thing that'll allow us to do is well, outside just being decoupled from the normal development cycle or release cycle of Volta, is being able to implement the networking pretty much in however we wanted to. So like in this case, we had VXLAN, but eventually, some customers will have specific ways they want to, run their networking, and it might not just always be IP. They might want to do, they do some very strange things in labs. So.
Yeah, I think if we speak about potential non-trellis, then as you mentioned, a couple of the elements of the control can actually be put on the switch right away, and then we have that running somewhere.
So from ISP perspective, I can see that in some small scale case, there is a good use case for the kind of SFP plus OLT. But if you want to do massive deployment in the CO environment, what is the biggest advantage comparing to white box OLT like all the other folks are doing?
Less space, more subscribers per box.
So if you look at the SFP plus, because of the power consumption, you actually have a pretty high heatsink, which means that your switch density cannot really be high because of that specific mechanical design. So comparing to the actual OLT, it may not really have high density, I would assume.
Well, it might depend on how your faceplate design actually is, because in a lot of typical, you have the dual row of SFP cages. So you plug the OLT in this way, heat sinks on top, and the bottom is on the bottom side of the board, and the heat sink actually goes down. So in many cases, I think, maybe not all, But in many cases, the heat sinks are actually, they don't, hit each other.
And even if you take this switch, you would potentially load it with 24 XGS PON ports. That's still 8 more than others?
No, this switch is actually 48 ports.
Yeah.
Yeah.
This switch is actually 48 ports.
Yeah, but
48
even if you just use the upper row
Yeah.
for whatever reasons, it's still a higher density.
Yeah. And since I
Plus, you
work
have
for-
120 subscribers per 10 gig. So the splitting ratio is 128.
And I would, working for Tibit, I would suggest just to fully load it anyway. So.
What about the per port cost, right? So what I'm saying is.
So I'm not sure what the actual retail is. Is it like 4?
I would say it's a competitive solution.
Yeah, it's,
Talk with anybody afterwards.
yeah. I mean, I know some of the retail numbers. I don't know if they're the latest or whatever the specials are, the AT&T special. I don't know, but I know they're competitive with a former employer of mine.
I'm just an engineer. I don't know about the price anyway. So.
Yeah.
In the picture, it looks like it was made out of gold.
Well, that's the marketing one. The engineering ones I have, they're not as pretty.
Plan to kind of integrate with technology profiles at some point?
Yeah. That's the next. First integration to the technology profile and the resource manager changes that are needed for the ONU communications. So that was one of the reasons I did 1.6 is it was fairly fixed and it was easy for the customers that are actually testing it in their labs. They wanted to be able to say, "Hey, I want to pull down the source, add your device adapter, and run." So, and of course this will be recorded, and you can track us down during after hours. We're always happy to talk
Yeah.
about things or share ideas. So.
I'm interested in the abstraction of Microplug OLT in Volta. I mean, is each single pluggable module abstracted as a single logical device, or a group of pluggable modules are abstracted as a logical OLT? Which one?
Yeah, each OLT is a single logical switch, and I actually sort of looked at trying to, would it make sense to try to aggregate those? And it looks like it would be fairly not too hard to do until all of a sudden you get into the problem of each of them provide a different, N and I port, and some of the open flow rules, since they're not typically like the typical Metro Ethernet rules, you can get some combinations that might pass the flow decomposer that would not work well.
I have a question because I think, Chip, you probably remember of this. When Volta, we want to introduce DPU as a second
Yeah.
open flow switch, right? So will that model, because right now the problem here, you have two open flow switch back to back, right?
Yeah.
For the one you're talking about, but will the same problem happen for the DPU scenario?
Not really, because I think you'd have different rules on how you would do your traffic, but the overall idea is that Volta is a Ethernet open flow switch. So, running one or two, or, two as a DPU Volta open flow switch and an OLT open flow switch. They're still open flow switches and all, so I don't see any issues. I think you'd have dependencies on your OLT switch because as soon as you hit the DPU, you might have more higher densities or more different VLAN tagging patterns and such.
Okay, thank you so much.
Okay, well, thank you.